Greetings everyone. I welcome you all to our today's lecture. Today we shall be talking about differentiation of trigonometric functions using first principles. I expect us to be having the knowledge of trigonometry as such that the differentiation of such functions will be easier for us. So what is important in trigonometry is basically some few important formulae. For example, we shall need to recall some important expressions, especially from factor formula for trigonometric functions. These identities will basically be important when we are looking at differentiation. So I hope you still recall the factor formula, and that is the factor formula for cos and the factor formula for sine. So when you are looking at cos of alpha plus cos of beta, then its factor formula will be equivalent to that. Then when you are looking at cos of alpha minus cos of beta, it can as well be equal to that. And then sine of alpha plus sine of beta will be equal to this one, that is its equivalent factor formula, and as well sine of alpha minus sine of beta will be equal to that expression. So you need to go back and try to relate some of these expressions, as they will be helpful when we are looking at differentiation. So we shall not waste much time. Basically, I will be showing you how best we shall use these expressions here. My assumption is at the moment you already know what factor formula is. You already know how to deal with compound angles. For example, if you are dealing with cos of alpha plus beta, you need to be knowing what it is equivalent to. If you are dealing with sine of alpha plus beta, you need to be knowing the expansion of this. So I believe we have the knowledge of trigonometry, and some of these expressions will be very important for us. So let us look at differentiation. So to look at differentiation, we shall begin with differentiating cos of x from first principles. So to differentiate cos of x from first principles, we shall first of all let us have y equaling to cos of x. So an increment in x, if you take an increment in x, for example, by delta x, will bring an increment in y. So an increment in x brings about an increment in y. So this brings an increment in y, which we can call delta y. So delta x and delta y are increments in x and y respectively. So we are saying an increment in x. So if you take an increment in x, it brings about an increment in y. So meaning this can be cos of x plus a small change in x, which is delta x. So from here we can take y the other side, and we shall remain with delta y, which is equal to cos of x plus delta x minus y. So this is delta y, which is equal to cos of x plus delta x minus y, but y is cos of x. So from here we can again recall what this one is equivalent to from factor formula. So from factor formula we said if you have cos of alpha minus cos of beta, it is minus of 2 sine of alpha plus beta over 2 sine of alpha minus beta over 2. So we shall use the same knowledge. We shall borrow the same knowledge from trigonometry, and we shall use factor formula here, and we shall have this as minus 2 sine of this angle, which is x plus delta x, then adding there this angle, which is x, and the whole of this is divided by 2. Then again sine of x plus delta x minus x, again this is divided by 2. So this will be same as having minus 2 sine of, I will try to simplify this expression. This is x plus x, which is 2x, but we are dividing it by 2. So that will give us x plus delta x upon 2. Then sine of x, and x will cancel out, you will remain with delta x upon 2. So this is our delta y. We are interested in getting the differentiation of cos, which means we are interested in getting dy dx. So for that case, we shall divide through, we shall divide through by delta x. So divide through by delta x. What will it give us? It will give us delta y upon delta x, which is same as minus 2 sine of x plus delta x upon 2, and then sine of delta x upon 2. But we are dividing both sides by delta x, so it is equivalent to having 1 over delta x at this side. So from there we shall take the limit on both sides when delta x is becoming smaller. So when delta x is tending to 0, we are taking a limit on both sides, and this will be same as limit when delta x is becoming smaller, that is tending to 0. So we shall have minus 2 sine of x plus delta x upon 2, and sine of delta x upon 2, then times 1 upon delta x. So that is what basically we shall have. So from there, we shall be saying that actually when delta x is becoming smaller, then delta y, delta x will be turning to dy dx. And at the same time, sine of a very small angle, if delta x is becoming smaller, then it means sine of delta x divided by 2 will approximately be equal to delta x divided by 2. This is important to note, especially if you get your calculator and you try to put sine of a very small angle, it will be same as that small angle. And cos of a very small angle, for example, cos, if you were to take cos of delta x upon 2, then this one will be approximately equal to 1. This will be approximately equal to 1, because cos of a very small angle, if delta x is tending to 0, then cos of delta x will be equal to 1, and sine of delta x will be approximately equal to that same angle. For that case, we shall be able to use this expression that sine of delta x upon 2, since delta x is becoming smaller, will be equivalent to delta x divided by 2 itself. So from that, this expression here will be simplified. So where we are having the limit of delta y, delta x tending to 0, delta y upon delta x, then this will be dy dx. So we shall have dy dx equaling to the limit delta x is tending to 0, and what we are having here is minus 2 sine of x plus delta x upon 2, then sine of a small angle here, sine of a small angle, which is delta x upon 2, the whole of this is becoming delta x upon 2. So this is times delta x upon 2, but we are also multiplying by 1 upon delta x. So from here we shall say limit delta x is tending to 0 of minus 2 sine of x plus delta x upon 2. This and this will cancel, and you will remain with 1 upon 2. So don't multiply this. This is an angle of sine, so don't multiply this with this half. So this one is outside, so it does not affect this angle here. So for that case, this 2 and this one will reduce, and we shall have the limit of delta x tending to 0 of minus sine of x plus delta x upon 2. So this is what we are remaining with. So if delta x is becoming small, it means this will be actually equal to 0. So it is becoming smaller, it is turning to 0. So wherever we have delta x, we shall put 0, and 0 divided by 2 will be actually 0. So we shall be able to remain with negative sign of x as dy dx. But what was y? Y was cos of x. So this implies that when you differentiate cos of x, you will be able to get negative sine of x. Let us now look at the differentiation of sine of x from first principles. So like the way we have done for cos, we shall first of all let y to be equal to sine of x. An increment in x will bring about an increment in y, and for that case, y plus delta y will be equal to sine of x plus delta x. Here we are having delta x and delta y as increments. These are simply increments in x and y respectively. So here delta y will be same as bringing y this side. So sine of x plus delta x minus y. But what is y? Y is sine of x. Likewise, we can easily see this is sine followed by sine, and that will bring us to what we call the a factor formula of trigonometric functions. So if you are having sine followed by sine, then and you are subtracting, we shall be using 2 cos of alpha plus beta upon 2 sine of alpha minus beta upon 2. So we shall employ that, and we shall have this as delta y, which is equal to 2 cos of x plus delta x plus x. The whole of this is divided by 2, that is applying factor formula. Then sine of x plus delta x minus x. The whole of this is divided by 2. So we shall try to simplify this, and we shall have delta y, which is equal to 2 cos of x plus x divided by 2 will be x plus delta x upon 2. Then sine of x minus x will go away, so we remain with delta x upon 2. So that is what we have. We are interested in dy dx, so we shall introduce in delta x. So let us divide both sides by delta x. So this will be same as 2 cos of x plus delta x upon 2, then sine of delta x upon 2. But we are dividing both sides by delta x, so let us have 1 upon delta x. So from here we shall take a limit. Let us look at the case in the limit when delta x is tending to 0. Here we have delta y then over delta x. This is same as taking the limit delta x tending to 0 of 2 cos of x plus delta x upon 2, then sine of delta x upon 2 times 1 upon delta x. That is what we are having. So in the limit when delta x is tending to 0, so we are saying when delta x is becoming smaller, then delta y upon delta x will be approximately equal to dy dx, and at the same time sine of a very small angle will be approximately equal to that same angle. So that is the assumption we shall make after taking the limit. So from there we shall be able to have dy dx, which is equal to the limit delta x is tending to 0 of 2 cos of x plus delta x upon 2 sine of a small angle, we saw it is that small angle, then times 1 upon delta x. Simplifying this further, we shall have limit of delta x tending to 0 of 2 cos of x plus delta x upon 2, then times this will be 1 upon 2. So this one is an angle for cos. So this and this will give us a 1, and this will be limit delta x tending to 0 of cos of x plus delta x upon 2. And this will give us delta x is becoming smaller. So if delta x is becoming smaller, this one will give us a 0, and this will be, there's no need of putting limit again. So this will be cos of x, where there is delta x, it becomes 0. So here we are substituting for delta x equaling to 0 because delta x is tending to 0, which will give this one as cos of x. So for that case, we shall have cos of x as dy dx. But remember that y was same as sine of x. That is what we had, was sine of x. And for that case, it means that when you differentiate with respect to x, sine of x, you will actually get cos of x. Let us now talk about differentiation of tan of x from first principles. So how do we differentiate tan x from first principles? The procedures are actually the same. So we shall first let y to be same as tan of x. So an increment in x brings about an increment in y. So this will be tan of x plus delta x. So delta y will become tan of x plus delta x minus y, which is tan of x. Now from here, you realize we don't have factor formula that involves tan. So for that case, we shall simply express tan in terms of its expression that is containing sine and cos. So this is x plus delta x upon tan is sine over x. It is tan is same as sine over cos, which means it will be sine of x plus delta x upon cos of x plus delta x. Then minus sine of x upon cos of x. So from here, we shall first of all get the LCM. LCM is cos of x plus delta x, then times cos of x. So when you get this divided by this, you will get that. Then this will be same as sine of x plus delta x times cos of x, then minus, when you get this LCM divided by that, you will get this, you multiply it here, so it will be sine of x times cos of x plus delta x. So this will give us delta y, which is equal to, when we look at this expression here, we have, if this is a, if this is a and this is b, this is b, this is a. If you recall very well, sine of a minus b is same as sine of a cos of b minus sine of b cos of a. So when you look at this and this one here, you realize this one is the sine expansion. So this is same as having sine of a minus b, which is x plus delta x minus b, which is x. So when you expand this, you get this. But we are dividing this by cos of x plus delta x then times cos of x. So that is what we are having. We can simplify this further. This will be sine of x. X will cancel and will remain with delta x upon cos of x plus delta x times cos of x. So that is what we shall have. So from there we shall divide through by delta x, which means this implies that delta y upon delta x will be same as sine of delta x upon, here we have cos of x plus delta x, then times cos of x. We are dividing through by delta x, so we have 1 upon delta x. So from that, we shall take the limit. In the limit, when delta x is becoming smaller, we take the limit on both sides, so this will be limit delta x is becoming smaller of sine of delta x upon cos of x plus delta x times cos of x. Then we are multiplying by 1 upon delta x. So from there we shall still take our assumptions that as delta x is becoming smaller, then delta y, delta x will be approximately equal to dy dx, will be turning to dy dx, and at the same time sine of delta x will be also approximately turning to that same angle, that is delta x. So meaning here we shall have limit of delta x turning to 0, where we have sine of this, it will be delta x upon cos of x plus delta x times cos of x. We are again multiplying by 1 upon delta x. Here, this is now dy dx. So dy dx will give us, so this will give us dy dx equaling to the limit delta x tending to 0. Delta x and delta x will cancel out, so we shall remain with that expression there. So this is dy dx, which is equal to, now we are remaining with the limit delta x tending to 0, and the only now delta x we are having is this. So if delta x is tending to 0, so this will be approximately equal to 0, and for that case we shall remain with 1 upon cos of x plus 0, it remains cos of x times cos of x. So this will be 1 upon cos squared of x, and this will be dy dx. So from there we know that 1 upon cos is same as sec, so 1 upon cos squared will be same as sec squared of x. So this implies that when you differentiate tan of x, you will be getting sec squared of x. Let us now talk about differentiation of sec x from first principles. Now, we shall still follow almost the same procedures. We shall be saying let y to be same as sec of x. And this implies that an increment in x will bring about an increment in y. So y plus delta y will be same as sec of x plus delta x. But we know that sec of x can be expressed in terms of cos. So here we shall be saying delta y is same as sec of x plus delta x minus sec of x. Here we don't have a factor formula relating sec and sec, so we must put it in terms of a cos. So this will be same as 1 upon cos of x plus delta x minus 1 upon cos of x. Like what we did for tan, we shall also get the LCM here. So the LCM for this will be same as cos of x plus delta x times cos of x. Get the LCM, divide it by this, you'll be able to get cos of x. So we shall have this as cos of x minus, get the LCM, divide it by that, you will get this. So cos of x plus delta x. So this is our delta y. Let us try to simplify that further. So delta y will be, looking at this, this is cos followed by cos. When you recall what we did say that when you are looking at cos followed by cos, then that becomes a factor formula. So cos of alpha minus cos of beta is -2 sine of alpha plus beta divided by 2 sine of alpha minus beta divided by 2. So we shall employ this same factor formula, and we shall be able to get the equivalent expression of this. So we shall say cos followed by cos is -2 sine of x plus x plus delta x divided by 2, then sine of x minus x plus delta x. The whole of this is also divided by 2. But we have the whole of this expression is divided by cos of x plus delta x, then times cos of x. That is basically what we have. We can simplify this further, and it will be able to give us delta y is same as -2 sine x plus x divided by 2 is x plus delta x upon 2. Then sine x will cancel with this, then we shall remain with negative delta x upon 2. But the whole of this expression is divided by cos of x plus delta x times cos of x. So that will be delta y. So the next procedure will be to divide through by delta x. So dividing through by delta x, we shall have delta y upon delta x is same as, here we are having -2 sine of x plus delta x upon 2, then sine of minus delta x upon 2. We are dividing by cos of x plus delta x, then times cos of x. So that is what we are having, but we are dividing through by delta x, so let us multiply this side by 1 upon delta x. So don't forget, if you divide this side by delta x, do the same at the other side. Now let us take the limit. Limit when delta x is tending to 0 of delta y upon delta x will be same as taking the limit on the right hand side as well of -2 sine of x plus delta x upon 2 sine of negative delta x upon 2. Then the whole of this is divided by cos of x plus delta x, then times cos of x. But we are multiplying by 1 upon delta x. So this, we shall take our assumptions that as delta x is becoming smaller, then delta y, delta x is tending to dy dx, and at the same time, sine of a small angle like negative delta x upon 2 will be same as negative delta x upon 2. So from here, we shall now have dy dx. which is equal to the limit delta x is tending to 0 of negative 2 sine of x plus delta x upon 2. Then this one will give us minus delta x. We are multiplying by negative delta x upon 2. We are dividing this by cos of x plus delta x times cos of x, but we are multiplying by 1 upon delta x. So this will give us limit delta x is becoming smaller of this is minus 2, this is minus 2 again, minus 1 upon 2. So this and this will cancel. So this will give us a positive. This is a minus, so 2 cancels out. Delta x will cancel with this. Then we shall remain with sine of x plus delta x upon 2 divided by cos of x plus delta x times cos of x. That is what we shall have. So we are saying that delta x is becoming smaller, and for that case we shall have dy dx, which is equal to, so whenever we have delta x, we are saying delta x is becoming smaller. So where there is delta x, we shall be putting 0. So this becomes 0, this becomes 0. In other words, we shall be able to have sine of x upon cos of x times cos of x. So we can have this as sine of x upon cos of x times 1 upon cos of x. Sine upon cos is same as tan x, then 1 upon cos is same as sec of x. So we can have this as sec x tan of x. This is dy dx. This implies that when you differentiate sec of x, you will always get sec x tan of x. Now, having looked at the differentiation of sec, you should now be in position to differentiate cosec. So you will use same procedures as we have done for the differentiation of sec. So here you should be able to show that when you differentiate cosec of x, you'll be able to get negative cot x cosec of x. Or you can simply write it as negative cosec x cot x. So it is the same thing. So you should be able to get this when you differentiate cosec of x. So try it out and let me know in case you are in position to get that. In case of any challenges, comment below and I will be able to guide you through. So let us look at the last trigonometric function, which is cot of x. Let us now look at the differentiation of cot. That is the last trig function. So we shall be saying that let y be equal to cot of x. An increment in x brings about an increment in y, and for that case we shall have y plus delta y, which is equal to cot of x plus delta x. So meaning delta y is same as cot x plus delta x minus, so you bring this one the other side, it becomes minus cot of x. So we don't have the relation or an expression that relates cot with cot. We don't have that factor formula. The factor formula is basically for cos and sine. So we cannot easily relate these two but we can easily put them in terms of cos and sine. So cot of x plus delta x is same as cos of x plus delta x upon sine of x plus delta x. Then minus cot is cos upon sine. So get the LCM, and after getting the LCM, you'll be able to remain with this expression. So from here, we can try to rearrange this to have sine of x, cos of x plus delta x, then minus, this will give us cos of x, then sine of x plus delta x. The whole of this is upon sine of x plus delta x, then times sine of x. So this will be same as, when you look at this expansion here, if this is A, this is B. This is A, this is B. So looking at this, this is an expansion of sine of A minus B. Sine of A minus B is sine A cos B minus cos A sine B. So that is what exactly we have here. So this can be expressed as sine of x. A is x, B is x plus delta x. But we are dividing this by sine of x plus delta x times sine of x. So looking at this, it will simply be same as sine of x, and x will cancel. This will be negative delta x upon sine of x plus delta x, then times sine of x. So in other words, we shall have delta y, which is same as sine of negative delta x upon sine of x plus delta x, then times sine of x. So let us divide through by delta x. So dividing through by delta x, we shall have delta y upon delta x is same as sine of negative delta x upon sine of x plus delta x times sine of x times 1 upon delta x. We are dividing through by delta x. After that, we shall take the limit. So in the limit, when delta x is tending to 0 of delta y upon delta x, you take the limit on both sides. Limit delta x tending to 0 of sine of negative delta x upon sine of x plus delta x times sine of x times 1 upon delta x. So this, we shall again take our assumptions here that if delta x is tending to 0, then delta y upon delta x will be tending to dy dx. Similarly, sine of a small angle will be same as that small angle, negative delta x. So this implies that dy upon dx will be same as limit delta x tending to 0 of sine of this, we are saying it is negative delta x upon sine of x plus delta x, then times sine of x times 1 upon delta x. So that is what we are having, and from there we shall have dy dx is same as limit delta x tending to 0 of negative 1 upon. So we're looking at this, you realize delta x will cancel out, you remain with a negative upon this. So that is what we are having here. Sine of x plus delta x times sine of x. So this will give us limit delta x tending to 0 of negative 1 upon sine of x plus delta x, then times sine of x. So from there, we shall be able to have, where there is delta x in this expression, we shall put a what? We shall put a 0, because delta x is tending to 0. So it means this will be 0. And this will give us limit. No need to put the limit now. We have taken the limit for delta x tending to 0. So we remain with negative 1 upon sine of x times sine of x. So this is negative 1 upon sine squared of x, and this will be same as 1 upon sine squared is cosec squared. So this will be same as negative cosec squared of x. So this will be dy dx. What does this imply? This implies that when you differentiate cot of x, you will get negative cosec squared of x. So in general, we can easily say that when you differentiate sine of x, you get cos of x. When you differentiate sec x, you get sec x tan x. When you differentiate tan x, you get sec squared x. When you differentiate cos of x, you get negative sine x. Cosec of x, you get negative cosec of x cot x. When you differentiate cot x, you get negative cosec squared x. So in this summary, we can easily see that for any trig functions which start with c, when you differentiate them, they bring about a negative. Cos, cosec, and cot, they all start with c, and their differentiation brings about a negative. So whenever you are differentiating a trig function that starts with c, don't forget about the negative. So that is where we shall stop for today. I encourage all of us to subscribe to this channel.